Hello everyone, I'm Tharundi Wickramasinghe. I'm an undergraduate at University of Peradeniya under Geographical Information Science degree program. In this video series, I really need to highlight the basic components that can use for mapping in this software, such as exporting, georeferencing, digitizing, and how to use buffers. Let's move to export data. Therefore, you have to go this icon, add data icon. We are going to add data. Click on add data. Then you can see your folders. Then you can add this data. LK admin data. Here I use LKA admin 1 shapefile. You can download this data from Diver GIS. Click add. Then Sri Lankan map appear like this. Then I go to export a particular district. Here I choose Badulla district. So I want to export this region. Therefore, first you have to go the select feature. Select feature. Click on it and come on the map and click again. Then it will appear like this. After that, go to the table of content and right click data, export data. Then you have to give a particular place to save this feature class. Click on this icon. Here I am going to save this in data folder. I am going to name it as Badulla output. Then give save. Press OK. Again yes. Then it will highlight it. After that, tick out this LKA admin 1 and go to Badulla output, right click and give zoom to layer. Simply this is the data export. You can export any district or any region like this. Next, georeference. Georeference used to convert raster data model into vector data model. Therefore, we need both raster and vector data in this session. So, add data. I'm going to add vector data first. I use the previous exported data. Click and add. Next, we will go to add raster data. Here I already downloaded raster data from the internet. Badulla raster data. Add. Then give OK. Then here you can see this is the vector data. By zooming you can identify vector data. Let's go to raster data. Again zoom. Here it is clearly represent raster data. When we georeferencing, you need to active georeference tool. Here I already active it. You can active this tool by right click on header and is this georeference. Here I already active. Then to georeference, first you go this view link table. Click. Here you can see there is a tick on auto adjust. You have to remove this tick and close this table. After that, you can start georeferencing by using this add control point. Click on it. easiness of the georeference, you can zoom this map like this. Then again start to georeference. Click a particular point and drag to the vector data model. Right click, zoom to layer. Again you can zoom this and paste that point. Likewise, at least 4 to 5 points you need to identify. This is my second. I'm going to use 5 points. Then this is my last one. Click, drag, zoom to layer, zoom it and paste this. After this process, again you have to go the view link table, and here it shows the selected points. Then you have to give command or you have to put tick on auto adjust and close this table. Then when you give zoom to layer, it will appear like this. This is the georeference. This is not a perfect one. It has some distortion. A perfect georeference you can't find like this. You can't find raster data under vector data because this one has a distortion. After you georeference, make sure you have to go georeferencing and update georeference. That is the last point. Then it will appear like this. Let's move to digitize. First, you have to add data. Here also I use Badulla raster data. Here raster data, Badulla, add. Then we need to prepare a shapefile. Therefore, go to the catalog and right click on this plus mark, then right click, new shapefile. Then name it as Badulla boundary. Badulla boundary. This is a polygon feature. Then select feature type as polygon. Then you have to give a coordinate system. Therefore, go edit. Here we use geographic coordinate systems. Click on this plus mark. Then click on world. Our geographic coordinate system is WGS 1984. Click OK and give OK. Then it will appear as a layer. After that, you have to give active editor. Here, editor. Right click on head. Editor. You can active editor. Then give command as start editing. And again go to create feature class. Then the feature class appear like this. Click this one. This is a polygon. Then you can start digitizing. For the easiness of this digitizing, you can zoom this raster data map and again click on polygon and start digitizing. This is a little bit complicated work and it takes much time. Likewise, you have to digitize whole map. After you digitize, finally you have to double click on the endpoint. Then it will digitize. When there is any error occur, you can remove it by using this cross mark. Click on this cross mark and press delete button on the keyboard. Then you can remove this digitizer and you can start it again. After that, after digitized, you have to give command stop editing. Then do you want to save your edit? Yes, of course, we need. Then give yes. Then it will be digitized. This is our output, digitized map. Our next topic is buffer. To do a buffer, I use topographic map. Moreover, in this video series, you can learn again export and how to clip a file as well as buffer. Therefore, first you have to add data. Here I use 75 topographic sheet. Okay, then this is the topographic sheet of number 75. In this practical, I use only hydro layer, places and transport. Just imagine this map going to represent a flood analysis. I have chosen flood affected area named Palmadulla, so you can get idea about how we can use buffer to flood analysis. In this map, I'm going to show what are the higher risk area of flood analysis. Therefore, I use only hydro layer, building layer and transport layer. Then other layers, no need. Then I'm going to remove these layers. Hydro layer we need, transport layer we need, terrains we no need, grid no, places we need and buildings no need. Then I'm going to, this is a Ratnapura topographic sheet. I want to export the Palmadulla area. Therefore, first you have to identify Palmadulla. Here, this is the Palmadulla. I export this as a separate layer. So I don't need this admin layer. I here add only Palmadulla output. I exported it before. Then remove. Alright, this is the Palmadulla area. So in here we need to remove the other parts. I need only Palmadulla hydro, transport and places. Therefore, you have to make separate clip files. Go geoprocessing, clip, and first I'm going to clip places in this Palmadulla map. Click on the places, and next this is the Palmadulla, and you have to select a place to save this data. Then clip. This is as a places Palmadulla. Places Palmadulla and save. Give OK. Then when it clipping, it takes some time. When your command is right, it will appear like this and it come as a different layer. This is the Palmadulla places layer. Then you don't need any more this places point. You can tick out. Then it will appear only places in this Palmadulla area. Likewise, we have to make clip files for transport as well as hydro. Again, geoprocessing, clip. Next time I'm going to transport. Here, export Palmadulla. Again, clip, transport, layer in Palmadulla. Save. OK. Again it is clipping. It is OK. Clip is OK. Then it will appear as this. Anymore, no need this layer. So you can remove these layers as you wish. Then you can zoom to layer. It will appear like this. Hydro layer. I'm going to symbol like this. Next, you have to create a buffer in this river area. Therefore, you can go geoprocessing, buffer. Input feature is hydro in Palmadulla. Here you can save it as a buffer folder. You can create a new folder, name it as buffer. Open. Then name it as hydro buffer. Save. You have to give a distance. Here I will give 200 meters. Here dissolve size type should be all. Okay. Alright, it will appear like this. Hydro buffer. You can change the symbols. Here's I use red color because I need to represent the high risk area. Right, this is the buffering. Here you can analysis how when it flood occur, these buildings and these roads which located within 200 meters could be in debt, because we can assume that it could flood up to 200 meters from the river. When we zoom it, we can clearly represent it. Here, this is the river. In here to here, it has 200 meters. When the flood occurs, higher risk area represent this red outline. Inside this red outline is the higher risk area. This is the buffering. We can use this buffer to analyze data. Likewise, there is a intersect. Intersect also same as buffer, but we use intersect as a to create standard maps, but the procedure is the same. Buffer and intersect do the same job. Another important thing is we can create multiple buffers. Therefore, we can use this arc toolbox. Here, analysis tool. Click on the plus mark. Then proximity. Click on proximity and the multiple ring buffers. Double click. Same as previous, you have to input a feature. Output feature class you have to save. Distance, you can enter different distance. 100 meters plus 200 meters plus 300 meters. This is there are 3 rings. After that, here you have to give a buffer unit, whatever, kilometer, meter, miles, whatever you want. Then finally, dissolve option is give all, give OK. Then it will appear different multi buffers.